Hello and welcome to Carolan Cymru revision sessions. In today's session, we will focus on WJC GCSE Physics, in particular the 2022 Foundation Tier paper. It will be presented by Dr. Nettle from e-sgol Cymraeg Yslyfera, and the session should last around 45 minutes where I'll hopefully work through most of the questions. If you have a question during the session, please use the Q&A section and we'll do our best to answer any questions. So over the past few sessions, we have looked toward preparing for the exams. Now that we're at the stage, hopefully, where we've fully prepared for the exams, we now are starting to look at questions, in particular, questions from recent past papers. And the focus of today's session is to look at the most recent paper, and in particular, the foundation tier questions. So we'll start by ensuring we have a good understanding of the exam front page, so we don't just rush past it or skip it. Understand how useful the equation page can be. We'll then have a look at working through the full paper, and in this PowerPoint I've also included the mark scheme at the end just to assist you if you want to use this resource in future. If you're watching this session back, you have the opportunity to pause when we reach a question and attempt the question yourself and then hit play to see how you got on. So first of all, the exam front page. So if you are sitting the double award science, you'll be sitting Unit 6, Physics 2, Foundation Tier, or higher tier, but today, Foundation Tier. You're aware it's an hour and 15 minutes, and in total, you should have 60 marks available from all the questions. So if we look at it as just over an hour for 60 marks, so not much more than 60 minutes, then realistically, if you're trying to practice your pace, you might be thinking a mark a minute. So when you see a 4-mark question, you might consider 4 minutes. That way then any additional time towards the end will be a bonus. Question 1 you see is 11 marks, so you might be thinking 11 to 12 minutes there. As you go down, you start to see maybe a little plan in your mind of how you should get on, and when you reach question 3, it might have taken you close to 30 minutes to reach that point, so that you know you're in a good pace, you don't feel rushed towards the end. Instructions, please be aware you should aim to use black ink or a black ballpoint pen and not a gel pen or any type of correction fluid such as Tippet. Please use pencils on graphs and diagrams. And another additional tip that we often need to see used is if you need additional space, please write your answers and link it to the question. So continue on page 12 and then please label it nice and clear. So 1A, so that way when it's scanned in for the examiners, it's very clear what questions you've had to continue. And the final thing to be aware, last week's session we looked at these QER questions, and they will identify on the cover where it will take place. And in this paper, question 4 will be the 6-mark QER question. So as we did a lot of that last session, when we get to that question, I'll just summarize how to target that question rather than answer it fully. The first thing you do once you open your exam is before even seeing question 1, you will see page 2 or that equation page. Be aware how useful this page can be. So when you get stuck on a question that's asking you to calculate something, always return to page 2 because you might be able to determine the equation through process of elimination. So if they give you time and acceleration, you might identify one equation over the other and then feel confident you can answer the question. Not only is equation page useful for calculations, it might be useful if you have a question involving a graph, because acceleration is found by calculating the gradient of a velocity time graph. And again, these are one of the things you might forget, so always come back to page 2 or the equation page to assist you. Before we jump into the question, some of the things you might want to remember for this year in particular, for 2023, is the advanced information for Foundation Tier double award science is that there's a large emphasis on practical work this year. That means some of the questions including half-life, Newton's laws, work and energy will have a practical element to it. So ideally, it'd be nice to see that in the 2022 paper to help us approach questions like that. So here we go. Question 1 is a question involving a number of cupcake cases being dropped from a height. However, the distance in which you measure the time it takes to fall is not the same as the distance in which you drop it, which is hopefully clear in the diagram. The cupcake cases are dropped 30 centimeters above the measured drop distance of 150 centimeters. First question is 3 marks and it's a underline. So please underline rather than circle your answers and make it clear which one you're underlining. And please do not underline all the options. Make sure you decide on the correct one you want to underline. So in this experiment, the independent variable is the 3 options below, which are number of cupcake cases, time of the fall, or height of the pointer. So hopefully you remember that in this experiment, if you had the opportunity to perform it or you've seen this experiment, you remember the thing that was changed, because the independent variable is that thing that you change, is the number of cupcake cases. It was decided to change the number of cupcake cases between 1 and 5, and that was the independent variable. As a result of this, part 2, the dependent variable, which is that variable or that thing that you will measure as a result of changing the cupcake cases, is that time of the fall, the duration it takes to travel 150 centimeters. If you think about it, part 3 is asking us what will happen, or during the first 30 centimeters of the fall, the cake cases are speeding up, slowing down, or falling at a constant speed. So hopefully you remember that terminal velocity is what occurs when you drop an object initially from 0 or rest, and it will accelerate. Therefore, it will speed up. It will speed up until it reaches a terminal velocity at the point 150 centimeters. Part B is asking us to draw a circle around the anomalous result when the 4 cake cases are dropped. So they've given us the information, 4 cake cases, which means we have to be looking at the number of cake cases. So a question like this is reliant upon us to read the question and also use the table correctly. So when you see 4 cake cases, your view should narrow in on this row here for 4 cupcake cases. Draw a circle around an anomalous data point. And what that means is anomalous is a solution answer or value that you've measured that does not fit the trend. So for 4 cupcake cases, what you hopefully see are values of 0.55, 5.6, 5.5 again, 7.5 and 5.8. So hopefully from identifying this, you will see that 0.75 does not fit that trend and should hopefully be an easy selection. The one thing you want to avoid is not reading the question fully and attempting to read the incorrect row. Once you've answered that correctly, we can move to part 2, which is calculate the mean time for 4 cake cases to fall that distance of 150 centimeters. So a question like this, what we'd be ideally looking at are the 4 values that do fit a pattern, and we would calculate the mean of 4 values. So the mean of 4 values is add the 4 values and divide by the number of values we added, which was 4. So 0.55 plus 0.56 plus 0.55 plus 0.58. If this has been done correctly, you get an answer of 0.56 seconds, and you want to look over it to see if it fits. So many issues can arise from using your calculator. So often it's useful to put brackets and calculate the top before dividing the answer by full, or calculating the top, hit equals, then hit the answer button and then divide that by full. It makes sense to the data here because 0.56 is within all of these values. It's greater than 0.55 and 0.55, but it's also less than 0.58. So it is in the data set we have. Once we've successfully answered this question, we can move on to part C. So part C is using some of the information that has been calculated, and that is use the table below to plot the data on the grid and draw a suitable curve of best fit. So identify here, there's 3 marks for a graph. That means the axes have been done for us. So they've outlined what they expect. So for number of cut cases, they've already outlined it on the x-axis. The terminal speed has been put on the y-axis for us. All we have to do is pair up the 0, 0 point and plot each point along. For 3 marks, 2 of those will be for putting the correct x's in the correct position, and then 1 will be for the curve of best fit. And a curve of best fit is done once with a single smooth line. If we look now, 1 and 1.7, ideally we see that going across 1, 2, 3, 4, 5 is where we'll be going. So we'll be going vertically up the value of 1. However, on the y-axis, all the answers are in 1 decimal. So you should check what is each box worth, and hopefully it's clear that it's worth 0.1. If you're not sure, you take the 10 boxes here, which is a gap of 1, and divide it by 10 to give you that value of 0.1. So now you know you can go to 1, continue up to halfway, which would be 1.5, and then 2 boxes above would be 1.7. We can repeat this for 2.2, which is 2 boxes above. Again for 3, which would be 2 and a half number of boxes. And the last 2 is 2.7, which if it's closer to the top, you might want to go to the top and then count down so you reach 2.7. And similarly, 2.9, you can go over to 4 and come down 1 box. So here we have a shape. We've plotted the 6 points in the correct place. Realistically, when we look at this type of graph, if we have one of them in the incorrect position, we might be looking at a loss of a mark. And if we have 2 in the incorrect position, we might look at losing the marks for plotting the x's. A smooth curve ideally will pass through all the points. However, we're looking for 1 smooth curve as nearest to the point as possible. I avoid going over them to try and attempt to make the curve look better or nicer in any way, because 1 single pass is what we're looking for. What we can do then is look at what other parts of the question we have, and that is complete the sentence below by underlining the correct phrase. So again, this question is asking us to underline the correct phrase. So we are expected to underline one of the terms. That means one of the terms in the brackets. And if you see, we have 1, 2, 3 terms for 1 pair of brackets, and the same thing again in the second. So identify that you have 2 answers here, which is why this question awards 2 marks. So what we do is read the sentence. As the number of cupcake cases or cake cases increases, so as we go along this axis, the terminal speed will increase. So as you can see, on 1 cupcake case, we have a value that's 1.7. As we increase to 4, the value is now 2.7. So as the cupcake cases increases, so does the terminal speed. However, you might find the trickier part of the question is seeing at an increasing, decreasing, or a constant rate. So this would require you to remember certain shapes. So a constant rate would be a graph in which the line does not change its slope. So the steepness is remaining the same, and that would be constant, which is not what we are seeing here. If it curved upwards like a slide, you would see that it is getting steeper as we go further up. If we were to plot little tangents, we might see that it is getting steeper. This would be an increasing rate. And in the example we see that it's getting less steep as you approach larger cupcake cases, which would be evidence of a decreasing rate. So 11 marks should hopefully have only taken us 11 minutes, possibly 12. That way then we feel confident that we have paced ourselves correctly. Question 2, what we see now is stopping distances of cars, which comes from 6.1. If we think of the advanced information for this exam, again, this topic, distance, speed and acceleration, has been ranked as the largest question in this year's paper. It may not have a large amount of stopping distances. It may be more focused upon speed equation, distance equation, or even the distance time graphs. However, this is the topic that has been identified as most marked. So we will take our time. So what we have is a statement that the total stopping distance can be calculated with the equation below, which is the thinking distance plus braking distance is equal to that total stopping distance. And we have a 3-mark question to put a tick or a cross. So that means do not leave them blank because you put one or either in each box. So that means every box must be filled to show whether the distance is affected by each factor. So we have our factors here. Worn tires has been completed for us. So thinking distance does not affect. Worn tires does not have an effect on our ability to think, which would cover the thinking distance. Worn tires does have an effect on the distance when the brakes have been applied. Therefore, the total stopping distance will increase. So a few ways to approach this is you could approach it from the start to the end. You could approach it from one topic at a time, or you could try and approach from the end back in. So if we were to look at each topic in turn, you think, right, thinking distance, you should hopefully identify that as the thought process. Your brain is doing the work, telling you to apply the brakes. So this is reaction. Drunk driver, is that something that affects thinking distance? I hope you agree it does. It would have a negative impact on the ability to think. However, a wet road should not hinder your ability to think about applying the brakes. That reaction time, which would not affect your thinking distance. If we think of the braking distance now, so this is the brakes have been applied. A drunk driver, once the brakes have been applied, there should be no effect on the ability of the car to brake it down to a complete stop. A wet road, however, once the brakes have been applied, it would have an effect on the friction and on how much it can slide along the surface, so we put a tick. Once we reach this point, hopefully we identify that total stopping distance is affected by the two, thinking plus braking. So if it's affected by one, the total is affected in both scenarios. So 3 marks, ideally each column correctly awards one of those marks. That's why we can ensure to put a tick or a cross in every single box. Moving on to B, we now have a question that says, at a speed of 13 meters per second, the thinking distance of an alert driver is 9.1 meters. So here they've given us the values, speed of 13 and distance of 9.1 meters. So to correctly calculate this, they have given us the equation. It's important that you identify the values you place on top and below. So distance of 9.1 has to go on top, divided by the speed of 13. Correctly inputting this to a calculator, we should get a value of 0.7 seconds. So 2 marks. What they look for here is a correct substitution with a correct result. So a good exam technique is identifying the correct terms for substitution. Part C. Again, see we have some of this information given to us at the bottom here, the thinking distance, and braking distance again, so make sure you see it clearly, see what's given. And we now have a driver of a car traveling at 13 meters per second, sees the traffic lights 30 meters ahead when the lights turn red. The thinking distance is 9.1 meters and the braking distance is 13.9 meters at this speed. Remember that the total stopping distance is simply the thinking added to the braking. Use all of this information to explain whether the car would be able to stop before reaching the crossing. So a question like this, where they've used the word explain, you clearly have space to calculate and you clearly have space to come to a conclusion. We expect, or the best thing you can do is explain or state if the car will come to a stop or would not be able to come to a stop. To do that, we calculate the total stopping distance by adding the thinking distance to the braking distance. So that value of 9.1 added to 13.9. This will give us a value of 23 meters. And now we can do a valid conclusion along the lines of either identify that the car will stop in 23 meters, which is less than 30 meters. So a statement along the lines of 23 is less than 30 meters. Or you can also identify that the car would come to a stop with 7 meters to spare because you understand that the total distance is 30. The distance we've just calculated is 23. So the car would have 7 meters to complete that journey to spare. So question 2, a total of 7 marks. So not many marks this year, last year, but this year we should see more. Question 3 now, the topic is springs. Clearly in the diagram, you should be thinking 6.3, work and energy, and similarly things such as Hooke's law. So we have a diagram that shows a spring being stretched by adding masses. The spring is stretched within its elastic limit. That means the spring won't be damaged and you think it still obeys Hooke's law. Diagram clearly shows a clamp stand secured with a spring, a number of masses and a ruler placed off to one side, with centimeters being the unit. Part of the method is shown below. So we have 8 steps, and for 3 marks we need to complete the number of steps using the letters A, B, C, D. So complete the method in bold by writing the letters A, B, C, D. So that means don't attempt to write the statement, just simply write A or B or C or D. So let's look at our statements. We have calculate the mean length for each mass, record the new length of the spring, repeat step 4, and calculate the mean extension. So if we look here, repeat step 4 for C might realistically come after step 4. So before we've even read the statements, we might think C might go here, only because of that clue right here. Now, if we look here, we have record the original length of the spring. So that means no mass on it. Record the original length. We then suspend the spring from the clamp and attach the 100-gram mass hanger. So we have the original length. We can see in the statements there is one to do with the new length. So B ideally seems to be the obvious answer because we have the original, we add a mass, and we will have a new length. Statement now says to add a further 100 grams and record the new length. So again, the statement here saying new length might help confirm the answer to B, the use of B beforehand. And we see by adding 100 grams, we've gone up in mass and a new length is measured. C fits into statement 5 because it does make sense to repeat step 4 until we reach a total mass of 700 grams. If we remove all the masses and repeat steps 1 to 5 once more, that means we'll have more value. So the question is, we have A or D for the last 2 points. So what we can do is either calculate the mean length for each mass or calculate the mean extension. So remember, mean, we need to have multiple readings, so they both terms make sense after 6. And to calculate extension, we first need length. So it makes sense that A would be before D. So a nice question here, we worked through the steps and we've used the process to eliminate terms and put them in the correct place. Question B, 2 marks, is to do with how to perform this experiment to the best ability. So one source of inaccuracy is measuring the length of the spring. State 2 ways this measurement could be improved. So seeing a statement such as length of the spring, hopefully you identify the equipment, which is the ruler, and the fact it's in centimeters. So the inaccuracy is coming from using the ruler to measure the number of centimeters in which the spring is extended. State 2 ways to improve this. So how to improve measuring the length? Well, think, how can we improve the use of the ruler? So if we look back at the diagram, we can see the ruler is at a distance away. So one statement we could do is to place the ruler closer or move the ruler nearer to the spring. The ruler in the diagram is standing upright, so realistically someone is going to have to hold it. You could also state that you would want to clamp the ruler vertically, so ensure the ruler is clamped vertically to avoid any issues with holding the ruler as near to vertical as possible. So statements to do with the ruler, such as move the ruler nearer or closer to the spring. Any question like this, it's very useful to identify what you mean by move it nearer. Nearer to which component are we specifying? The second one, again, identify the ruler. You might want to clamp or ensure the ruler is clamped vertically, so it's secure in place. We don't have to worry about it moving during the experiment. So the first 2 questions are quite wordy. Understand the method for the experiment. Now this question C is looking at, here's information. Can we use that information to calculate a few things? Such as C, the spring has an extension of 8 centimeters when 400 grams of mass is suspended from it. So what we can do is look at part I, which is, what does this weight correspond to? For 400 grams in mass, we expected to calculate it as newtons. It's a 1 mark question, which means it's not necessarily a question that requires an equation or a large calculation. However, they do provide this here. The idea that 100 grams is 1 newton. So we work backwards, 2 newtons would be 200 grams. And hopefully you can see why this question requires less calculation, but to use this information. So 400 grams would be 4 newtons. Part 2 is to use an equation. That's why we see 2 marks awarded here, to calculate the spring constant if we have the combination of weight and extension correct. Remember, if this value is wrong, you do have the opportunity to use part 2 equation correctly. There'll just be an issue of error carried forward, but it shouldn't hinder you from gaining those 2 marks because you can still do this section correctly. So the weight in our example is 4 divided by 8, and that would equate to a half or 0.5. So the spring constant for this question is 0.5 newtons per centimeter. If we move to part 3 of this question, it's a statement that says, John says that a mass of 200 grams would stretch the spring by 2 centimeters. Explain whether his claim is correct. So again, a question would explain you have to identify correct or incorrect, or it's a true statement or it's a false statement. So here, what we might see is if we remember that 400 previously produces an extension of 8, then if we think about it and remember what we learned about Hooke's law, in which they are directly proportional, if we halve 400, we would get 200, and we would expect the same to happen to the extension, and we'd expect an answer of 4 centimeters to be obtained. So this type of logic relies on us remembering that Hooke's law is this idea that the springs will stretch in a relationship in which they're directly proportional. So you could double the 200 to 400, and so would the extension double. So for 200, we would expect an extension of 2 centimeters. So we do have to point out that the claim of John is incorrect or John is false. We have to make sure we understand that we can demonstrate that it's not correct. Question 4, this question we spoke about earlier, in which it's a 6 marker. We can look at what we learned in the previous session for 6 mark questions because of the element of a quality of extended reasoning being assessed here. So they're looking for you to write comprehensively with a sustained line of reasoning. But what we can do is quickly outline how this question should be best approached. So what we see is a velocity time graph that shows the motion of a car for 30 seconds. So identify time is on the x-axis, velocity is on the y-axis, and you might remember a few things such as page 2 is somewhere you can go to identify that the slope or the gradient is equal to the acceleration. The question asks us to use data from the graph to describe the motion of the car. No calculations are required. So here, what you might be wanting to do is looking at the question, break it down into the number of sections so you can fully detail your answer. So hopefully you see there are 3 different sections to this answer. We could break this down into the A to B section. We could break it to B to C and C to D. So we can approach it in that style. Remember, 6 mark questions, we avoid the bullet points and we write an extended reasoning. So data we want to use for A to B, we are looking at a velocity changing from 0 to 6. So we could use the word accelerate. So we could describe that change corresponds to an acceleration. The time in which A to B occurs is from 0 to 5 seconds. So again, this is the information that would fit it. You would have to write it in a structured format. B to C, we see that the velocity remains constant of 6 meters per second. So the word constant would be a key word here, a constant velocity, and the time in this sense is from 5 to 20 seconds, which is a period of 15 seconds. So again, we can use this information to write a structured paragraph to help structure a good answer for the full marks. C to D is the final section where the velocity this time changes from 6 to 0 meters per second, which is a deceleration. You can see that the time which this takes is 20 to 30 seconds, and that would be a 10-second interval. So from breaking this question down into sections A to B, B to C, and C to D, we now have 3 clear different paragraphs we could write. we've identified the keywords we could put into our answer, and we can see, are we answering the question? Are we using data? Well, through identifying these numbers, we're not just using keywords, we're identifying the numbers to describe the motion. There are no calculations because we could go back and calculate the acceleration and deceleration. However, it's not needed in this question for the 2022 paper. What we can do now is move on to question 5, which is where we see a radiation and half-life question. In this particular question, we see a question to do with radiation, and we have a pie chart that shows the percentage of background radiation. So hopefully you recall that background radiation is that radiation is present in the environment around us, and the area in focus here is Cornwall. So hopefully in your studies you got to learn that Cornwall is an area where there's a larger amount of radon gas, if you recall that. Use the following information to complete the key for the pie chart. First statement is 50% or around 50% comes from radon gas. We can see from the pie chart we have sections D, A, C, B, or A, B, C, D, and we have to use those letters to complete the key. What we see is 50% comes from radon gas, so we can put in the letter D here for radon gas. Now we can look at the other sections. We see that A is near to quarter or 25% of the pie chart. We look at the second statement, which is 25% comes from the ground, buildings and medical. So we can put A in here. And hopefully we look at B, C, which are left, and identify that B is a larger amount of that remaining 25%. So we have 15 for cosmic and 10 for food and drink. With B being the larger amount, we can hopefully identify that B is cosmic rays, therefore C is the answer that goes here. So D, C, A, B. Part 2 is identifying the background radiation from radon gas in mid-Wales is smaller than in Cornwall. The background radiation from all other sources remain the same. Alan states that the pie chart for mid-Wales would be the same as the one above. Explain whether you think Alan is correct. Again, explain means that you have to show reasoning and identify if they're correct or incorrect. So we can look at this now and think about it. If there is less radon gas, that means you'll be going from 50%, which is half here, to a smaller percentage. As all the other ones would remain the same, they would take up a larger percentage of the total amount, which would mean D might shift to a smaller amount and B might take up a larger, C would take up a larger percentage, and so too would A. So what would happen is radon gas, the first thing you can identify is that the radon gas section would decrease or get smaller. Radon gas section would decrease. So here we've identified the first change we would see. How would this affect the overall? We could say other sections would increase as a result, because the other section amount of radiation might stay the same, but they take up a larger amount of percentage. And the final thing we could do is identify that Alan's statement is false or incorrect. Part B, what we can do now for part B is quickly look at a question, 1 mark, 2 marks. So we're looking at 3 minutes to answer a question like this. We have the isotope polonium-210. It has a half-life of 140 days. and it is a source of alpha radiation. So straight away, this question has given us a lot of information. We have 200 grams of polonium-210, and it's stored in a locked cupboard. The question asks us, or says, that the mass of polonium-210 will halve in 140 days. What else would change in that time? State one other quantity, so in bold. So hopefully from your lessons you may have learnt there are multiple answers that can go here, such as the activity. So the rate of that radiation that's been emitted, the activity of it may also halve in that amount of time. Or the number of nuclei is another way of saying it, or a similar way would be to say the number of polonium-210 atoms. However, make sure you place one correct answer on the line. Using this information and this understanding of half-life, complete the table below to show how the mass will change with time. So hopefully you see 140 is that single half-life. The next one down is again 140 added on, and same thing on the last one is 140 added on. So all we have to do is calculate the half value each time working down. So 200 to 100, 100 to 50 because we just halved 100, and then the final answer is 25 because we half it again. So this question's a nice question if you remember the topics within isotopes and half-life. The third part of the question is to complete the table for polonium-210. So if we write down the symbol 210, polonium, and 84 on the bottom, it's not a question that you can just make up. It's a question where you have to remember what and how to obtain these values of nucleons, protons, and neutrons from the way they write it here with the element and corresponding numbers. So hopefully you remember that the number on top corresponds to the nucleon number, the number of total neutrons and protons inside that atom. The final bit here now, polonium, the number value on the bottom of 84 corresponds to the number of protons, the proton number, which would be the number of protons inside the nucleus, which would be 84 in this question. And then finally, that 210 and 84, if 210 is the total number of nucleons and 84 corresponds to the number of protons, then the difference between these two numbers, 210 minus 84, would correspond to an answer of 126, and this would be equal to the number of neutrons inside the atom. So 126 would be the final value. So this 11-mark question now puts us at the end of question 5. We have 2 minutes left in today's session, but if I quickly change the question 6 and 7, what you might see is question 6 here is a question on work done and potential energy, or the topic work and energy. And this question is the first question from the higher tier paper. So this is the question that overlaps with the content from the higher tier paper. And similarly, if I move to question 7, this 2 again is the question that overlaps with the higher tier paper, which is a question to do with stars and planets. So what I can do today now is leave question 6 for next time. If you can, in the time between now and then, look at the past paper and maybe work through those questions yourself. That way then in the next session, you can come to the session with your answers and compare as we go through it live. So thank you for everyone that's tuned in today. The next session next week will focus on the 2022 higher tier paper, and I hope to see more of you again next time. Thank you for joining.